For this section in 8.2, we're going to be working on determining if a relation is a function. So there are two specific skills in this. We're going to be able to convert the ordered pairs that we worked on last section. And remember that our ordered pairs always go x, y. We are going to work on converting between tables, graphs, mappings, and a list of points. And we're going to identify the domain and range. We're also going to work on determining whether the equation or the ordered pairs is a function. So first things first, let's first start with talking about the domain. So the domain is the input or the x values of the ordered pairs. So if I have in this, for example, in this list here, I've got the ordered pair of 1, 1, 0, 2, 3, negative 2. The x values here of 1, 0, and 3 are the domain. Now, the range of the function are the y values. So we can look and see that it's 1 to 1, 2, 2, negative 2, negative 2. Okay, so each one of these lines here represents the ordered pair. Likewise, so we could do it here on a table. We can also do the same thing on a graph. So my first point here is positive 1, x, positive 1, y. My second point is 0, positive 2, so it's there. And my third point is 3, negative 2, and it's there. Okay, so we can either show this with a table, which we've worked with tables lots in the past, a graph, and then this here might be a little bit new to us, and it's called a map. So it looks a lot like a table, right? The only thing that seems to be different is that we draw arrows to the numbers where it corresponds to. So now when we're writing out what the domain and range of the set of ordered pairs, we want to put it into brackets. So I have 0, 1, 3, oops, and a comma between, and then I have negative 2, 1, and 2. So let's take a look a little further down. So let's have this example here. So we've got these three ordered pairs, so let's write them out. So we've got negative 2 and negative 1, 3 and 3, 4 and 3. Okay, so that's my table. So let's take a look at our map. So our x values are negative 2, 3, 4. My y values is when it's negative 2, the y value is negative 1. When my x value is 3, my y value is 3. When my x is 4, my y value is 3. So I drew a line and I drew another 3, but actually that's not even what I have to do. Let me show you how we would actually do this. So when I have two y values, all I have to do is draw an arrow to the same y value. So I don't even have to draw another set. So then let's do our graph as well. So our graph says negative 2, 1, 2, negative 1. I'm putting my dot there. Then 3, 1, 2, 3, and 3. Put my dot there. And then 4 and 3. So I put my dot there. Okay, so those are my dots. So now I want to look at the domain and range. For me personally, I actually like looking at the map, and I'm not sure why, but we're all going to have our own little different things that we like. So my map is already in numerical order. So for the domain, which again are the x values, so I'm just going to make this little note here for us, is negative 2, 3, and 4. And my range or my output is going to be negative 1 and 3. So I don't need to write 3 twice because I only need it once. Okay. So now we're going to take a little peek and we're going to look at if we can determine if the ordered pairs that we've been given, if our ordered pairs are going to be a function. So there's two different ways that we can do that. So the first way that we can determine if the set of ordered pairs, so in this example we have right here, we've got 6, negative 3. These are our different ordered pairs. in order for them to be considered a function, the x values can only have one y value, okay? So here's what I mean by that. So I went ahead and mapped out my x values. So let me just label it really quick. So my x values were 6 and then to -3, 4 to 1, 7 to -2, -3 to 1. Okay, so for every single one of these x values, I only have one y value. So if I'm asking if this is a function, my answer would be yes, because there's only one y value for each one of these separate things. Okay, that's the first way to look. The second way to determine if it's a function is what's called a vertical line test. And the vertical line test is saying that if we draw a vertical line through each value of x, the vertical line passes through just one point on the graph. So if I'm looking at this particular line, so what they're saying is I can pick any spot on this. Let's do a different color then. Let's do, we'll do purple because I like purple. Okay, so if I could pick any number for x, and it didn't do purple for me. There we go. So if I could pick any number for x and draw a straight line, and you just want to be better than Mrs. Johnson because you know I cannot draw straight lines to save my life. Okay, so, but did I hit any other x when I drew this line? No. So let me try again. I did it. I didn't hit any other line. So yes, this is a function. Okay, so let's look at this in practice. So we have a couple of different things here. So I have a couple of graphs. So I'm going to just do a vertical line test. So if I draw a line through each one of these points, if I do not hit another point, then I know that yes, it's a function. So let's do the same thing here. I'm just going to pick a couple of places to draw a line, and I did not hit this line more than once. Okay, so that means that yes, it is a function. So let's look at this one here. So we can't tell if it's a function because there's not a graph, but we're going to use this method here, which says that for every x value, there can only be one y value. So let's look here, but look, here I have x has, when it's x is -1, it is both 4 and it's both 5. So it's not a function. We cannot have more than one y value for each x. Okay, let's take a look at a couple of other examples. I have this, when it's 4, it's 2. When it's 2, it's 3. When it's 6, it's 1. I only have one y value for each x, so that's a yes. So here are my x's and my y's. When x is -3, it's -3. So I'm going to erase the second 4 here because I don't need it. When x is -3, it's 4. When x is 2, it's 4. Now, this is going to seem a little bit wonky, right? Because I've got two different, I caught my own error. Here we go. Actually, it looks like right here. When x is -3, I had -3 twice. So when x is -3, it is both -3 and 4. So it is not a function. Okay, here I've got -1 to 0, and when it's 1, it's 0. This is a function, okay? Because -1 and 1 are two different numbers. It doesn't matter about the output, it just matters there. So the y can have more than one x, but the x cannot have more than one y. So the last one I wanted to show you guys really quickly before we wrap up, I will show you the Desmos to be able to look at this equation in Desmos to be able to do it. So that's how we figure out the vertical line test and to do the mapping in order to determine if it is a function.